Today's topic is rate or rates. They're very similar. Rates and ratios are very similar. If you recall, back in February, a few chapters ago, we talked about ratios. And today we're going to talk about rates or rate. So the topic is very similar. Both ratios and rates compare quantities. Remember, we would say 5 horses to 3 pigs on the farm, something like that. Rate, we compare different quantities. Let's take a look, different units that are not related to each other, not like horses and pigs or horses and cows are all farm animals. When we talk about rates, we compare different units to each other, but it's also rate, just like a ratio, is a way to compare quantities in mathematics. So let's take a look. A machine fills 60 similar bottles of syrup in 5 minutes. And how many such bottles of syrup can it fill in 1 minute? Well, the math here is very simple. If we have 60 bottles and it takes 5 minutes to fill them, so in 1 minute, we will have 5 times fewer bottles, right? We will have 12 bottles because we reduce the time 5 times, and therefore we reduce the amount of work accomplished 5 times. So there will be only 12 bottles. We can say that the machine's rate of work is 12 bottles per 1 minute. Okay, we can say that, 12 bottles per 1 minute. Next example, Robert is paid $20 for working 4 hours. How much is he paid per hour? Notice these words, per hour. Well, here math is also very easy. 4 hours, $20, therefore he's paid $5 per hour. Notice the language, $5 per hour. Next question. Water is flowing from the tap at the rate of 100 liters every 40 minutes. Find the rate of flow of water in liters per minute. Liters per minute. So how much water comes out every minute? Well, 100 liters in 4 minutes, therefore 25 liters. Notice the language of the answer. 25 liters per minute. Notice this key word, per hour, per minute, per hour. Okay, so we're comparing how much water comes out in 1 unit of time. Next example, a machine makes similar toy cars at the rate of 120 per minute. Okay, they give us the rate of work, 120 1 minute, 120 next minute, and so on. How many such toys will it make in 6 minutes? Well, it will make 6 times more, right? So 12 times 6 is 72. 120 times 6 is 720 toy cars in 6 minutes. Next use case, a lamp can flash 5 times per minute. Again, notice this language, 5 times per minute. That's how much work it accomplishes in 1 unit of time. At this rate, again, this word, per minute. How many times can it flash in 30 minutes? Well, it's just going to be 30 times more, right? 30 times longer time, 30 times as much work will be accomplished. So 150 flashes in 30 minutes. Let's consider more examples. Water is flowing from a tap at the rate of 25 gallons per minute. Again, notice the language. We're using that word per, meaning every minute 25 gallons is coming out of this tap per minute. How much water can be collected from the tap in 5 minutes? Well, notice how we can structure this problem, right? Now we're using little, small time drawing. Notice 1 minute, 25 gallons. 5 minutes, clearly it is 5 times more. We're increasing the time 5 times, therefore we will increase the amount of work 5 times. And 125 gallons will be collected after 5 minutes. So the answer here is similar, very simple math, 125 gallons. Next, how long will it take to fill a container of capacity 100 gallons? Again, notice it takes 25 gallons. 25 gallons to fill up in 1 minute. So 1 minute is 25 gallons. That was given to us by the problem. What about a single gallon? Well, look what happens. We are reducing the capacity 25 times. What we do to the left, we must do to the right, right? To keep it all as what we call in proportion. Therefore, it will take 1/25 of a minute. Therefore, how about 100 gallons? How long will it take to fill up 100 gallons? Well, it's 100 times more. 1 gallon is a tiny fraction of a minute. Therefore, 100 gallons is 100 times more, right? So it will be 100 over 25, which is the same as 4 minutes. It will take 4 minutes to fill up the container of 100-gallon capacity. Finally, last example on this page. Mrs. Ricci types 45 words per minute. Again, notice this words, this language of ratios. We use this word per unit of time, right? In this case, 1 minute. At this rate, how long will she take to type 135 words? Again, we are given rate per 1 minute, 45 words in 1 minute. Well, therefore, we can see, what about one word, right? This is 45 words. This is one word, 135 words. So it's divide by 45 times. So the typing rate of one word is one word in 45th of a minute. And therefore, to type 100 words, well, to type 100 words is just 135, right? We know one word, so to type 135 words is 135 divided into 45, and that is, I believe, 3 minutes. So it will take 3 minutes to type 135 words. I hope you're getting a hang of it. Next example. A car can travel 96 kilometers on 8 liters of gas. Well, that is a very important ratio they're giving us. It's not 1 liter of gas, but it is a starting ratio that is very useful to us. That is what's given. 8 liters, 96 kilometers, it takes 8 liters of gas. The rate is blank kilometers per liter. Notice, they're asking us, how many kilometers does the car travel on 1 liter of gas? So, if it takes 8 liters for 96 kilometers, so it will be 8 times less, right? 8 times less. Notice, 8 liters, 96, we can find unit rate. My friends, this is called unit rate. 1 liter, right? Let me highlight. 1 liter will last you for 12 kilometers. Well, if 1 liter takes you 12 kilometers away, what about 15 liters? Well, of course, it's 15 times more, right? 15 times more. 15 times increased capacity of your gas tank, and therefore it will last you that much longer. 15. So 15 times 12, I will let you do the math. It's 120 plus 30, let's just say 150 kilometers. No, it's more. It's 180 kilometers, Miss Natasha. It will take you 180 kilometers away on 15 liters of gas. So the next question is, how much gas will be used if the car travels the distance of 120 kilometers? Again, look at what was given to us by the problem. This was given. 96 kilometers will last you will require 8 liters. Well, what about 1 kilometer? What about 1 kilometer? Well, that's clearly 96 times less, right? So we reduce the distance 96. We have to reduce the need for gas 96 times. So it's 8 out of 96 of a liter. And now to figure out how long will it take for 120 kilometers, we have to just take it that many times. So you have multiplication here, right? You have multiplication. 120, it takes, think about it, 1 kilometer, right? So it's 8 liters for 120 1 kilometer, right? One of these kilometers, if it's 1 kilometer, it takes you 8 out of 96. Let's simplify it, friends. It's 1/12. 1/12 of a liter of gas, right? That's how long it takes. So what about 120? It's 1/12, right? This is 1/12 times 120. Okay, so it will require 10 liters of gas to make a trip. It's going to be 10 liters. 10 liters of gas to make a trip that's 120 kilometers long. Next question. Next question. A photocopier can print 12 copies. 12 copies in 48 seconds. Look what is given. 12 copies in 48 seconds. Look how we write it. 48 seconds takes 12 copies. Let's put the units because they're important. Copies. At this rate, so they gave us a starting rate. It's not a unit rate. It's not a rate for 1 unit of time, right? We have 48 seconds, no problem. How many copies can it print in 1 minute? Well, if we are not giving the work per 1 second, let's find out. To find 1 second, it is just what we do. We divide by 48 times, right? What we do to the left, we do to the right. That is equivalent of 1/4, right? So in 1 second, it takes a quarter of a page. It prints a quarter of a page. So it takes 4 seconds to print 1 page. What about 60 seconds, right? 1 minute is 60 seconds. Okay, we increase the time that we want 60. Therefore, the amount of work will be increased 60 times, and 1/4 is going to be 60 times 1/4, which is 15 copies. Will be 15 copies.